Welcome to multiple choice question 19 of the 2008 Mathematical Methods Exam 2. In this video we will be looking at the solution for this question. A reminder that this video is in no way endorsed by VCAA. And now just before we move on, I'd like to point out that the use of the CAS calculator is not suitable for answering this question, as there's no straightforward way to enter the information that we are given. So for question 19, the graph of f is shown, and the graph of an antiderivative of f could be one of the following. So what I'd like to do is start by actually framing this as saying that the graph that we're given is actually the derivative graph. So let's call this dy dx. So now what we're really asked to do is go from a gradient graph to the original graph. So what we need to do is we need to think about what is this derivative graph telling us about our original function. So just to make that clear, if we're asked for an antiderivative of f, that means f is the gradient graph of the function that we're asked to try and get a sketch of. So first of all, we can see that this graph never reaches 0. So that means that there'll be no stationary points on the graph of the antiderivative. So this one has a stationary point here and a second one there. So that means that A is not an option. C has a stationary point here, so that is not an option. And the other graphs all could be options for this particular question. So we need to do a little bit more investigation. So this point here, that is the maximum value on the derivative graph, dy dx, tells us that there is a maximum positive gradient at x equals 0 on the antiderivatives graph. So that means somewhere on our original graph, we must have a positive maximum gradient at x equals 0. So that's where the curve has the greatest slope in the positive direction. This part of the graph out here, if I just color that in orange, means that we have all positive gradients getting bigger. And again, there'll be small positive gradients here, and there'll be larger positive gradients here. And now on the other side, we can make a similar analysis. So these are all positive gradients as well, and they are large here, and they get to be quite small as x gets bigger. So in our orange, this could be a small positive gradient leading into that maximum positive gradient that we get in blue. And then on the other side, they're going to progressively get smaller as the gradients of that function, but they're still all going to be positive. So there's a possible shape for our graph. And the only one of those graphs that it could possibly be is option B. So this describes that we have small positive gradients getting bigger and bigger and bigger, and then the gradients remain positive and get smaller as x goes towards infinity. So option B is a graph that the antiderivative of f could be. From the examiner's report, we can see that only 50% of students got this question correct, so it wasn't overly well done in this exam, with lots of students getting option A as their answer, which you would have obtained if you sketched a derivative of the graph of f rather than finding an antiderivative of f.